Hello students, so today's topic what I have picked is Lorentz force and induced EMF. So these kind of questions are asked in JE as well as CBSE many times. We have to calculate the induced EMF of a moving conductor inside a magnetic field, or maybe the magnetic flux is changing and we have to calculate the EMF inside a conductor. So here the question says a metallic rod of length 1 meter is rotated with a frequency of 50 revolutions per second. There is a metallic rod of length 1 meter. It is rotated with a frequency of 50 revolutions per second. Okay, one end is at the center of the and the other end at the circumference of the circular metallic ring. One of the end of the rods is hinged at the center, and the other end is at the circumference of a metallic ring of radius 1 meter. The radius of the ring and the length of the rod are the same. Okay, so this rod is rotating in a about a axis which is perpendicular to the plane of the ring. So this is the plane of the ring, and this rod is rotating like this. So this is the axis of the rod. So this axis is perpendicular to the plane of the ring. A constant and uniform magnetic field of 1 Tesla. There is a constant and uniform magnetic field of 1 Tesla parallel to the axis present everywhere. Okay. So what is the EMF between the center and the metallic ring? So what is the EMF between the center? Let's name it as O, and at the circumference of the metallic ring. So let's name it as A. We have to calculate the EMF at between O A. So how do we proceed here? So we know that whenever a charge is moving inside a magnetic field, it experiences a force. And that force is known as Lorentz force, and it is given by F is equal to QV cross B. We all know that. This Lorentz force is given as F is equal to QV cross B. So Q is the magnitude of the charge, V is the velocity of the charge, and B is the magnetic field in which it is moving. Okay, so as we know, this metallic rod carries free electrons, and those free electrons are moving perpendicular to the magnetic field. So they will experience this force, and this force, because they are perpendicular, will get reduced to QVB. QVB. Because they are perpendicular, the vector product will become a simple product. Okay, so here we will substitute the value of the charge. Charge is nothing but E, and velocity is nothing but omega times of R. Omega is the angular velocity of the rod. R is the radius. R is the distance from the center at which we are at a point which we are considering where we are calculating the force. So suppose we are calculating the force at this point, then R is the distance of that point from the center, and we are putting this value, putting this R here. So times of B. Okay, so we get E omega R B as the force on the charge which is situated inside the rod. So moving ahead, we are supposed to calculate the EMF. What is the EMF? EMF is work done over charge, and work done is given as F dot dr. Okay, suppose this charge here moves a distance dr. In moving this charge from here to here, we have the work F dot dr, and the charge is nothing but the charge on the electron. So moving ahead now, so we substitute the value of F here, we get E omega R B times of dr over E. This E will get cancelled, so we get dE is equal to omega R B dr. So we will now integrate from here to here. We will integrate. So at center the EMF is 0. At point A, you can say at the circumference of the ring, the EMF induced is E. And here the radius is nothing but, I will integrate from 0 to R. This distance is changing from 0 to capital R. R is the radius of the ring. Okay, so now let's integrate. Omega times of B times of R square over 2, 0 to R. Okay, So we will get omega b r square over 2, and which is, when we substitute the values of what is omega? Omega is nothing but 2 pi times of mu. Mu is the frequency of rotation, 50 revolution per second. I multiply it by 2 pi, it will give me omega, multiplied by b, multiplied by r square by 2. So I will now substitute the values. I will get 22 by 7 multiplied by 50 multiplied by 1 multiplied by 1 squared is equal to, when I solve this, I have substituted the values of mu, which is 50, pi 22 by 7, b1, r radius of the ring, or you can say length of the rod, both are same, it is given by 1. So when I solve this, I will get 157 volts. So this is the answer. So the EMF between the center and the circumference of the ring is 157 volts. If you like the video, please like the channel and subscribe the channel. Thank you.